Hello, everyone. My name is Alex. I'm officially head of MLOps and DevOps at Zencoder. But because it's a startup, I also have to wear many hats, so I also double as DevRel, speaking on the conferences, and in general, what I like to call Dev Ask Me Anything. Now, in this presentation, we will go through sort of the progression of AI assistants, AI coding assistants, from the past all the way to the present, and then we will see some glimpses of the future and how it might unfold for us, for the developers. And throughout the presentation, I will be using as a sort of analogy the levels of self-driving autonomy. Now, if you're not, that's the agenda for this. If you're not familiar with those levels, basically there are 5 levels of self-driving cars autonomy, ranging from something simple like driver speed assistance all the way to full autonomy. And well, there are technically 6 levels if you count no assistance. But yeah, if you're talking about at least some automation, there are 5 levels. And as you might have guessed, this image was generated by ChatGPT. So unfortunately, it still didn't learn how to center diff. Now, let's basically go through all the levels. Now, level 1 of driver assistance is essentially when GitHub Copilot was first released, and it was almost 4 years ago now, although it feels kind of like eternity, I guess, at least for me. And at that time, it was essentially just an LLM wrapper around LLM, and it was able to answer some questions. It was able to give you code completions, but as any code completion, any completion on steroids, basically, it was sometimes given some nonsense. It still was helpful to some extent, right? Especially if you wanted to get some quick answers, not to go to Stack Overflow, but just get some answers in the IDE. But unfortunately, it wasn't that helpful. Now, fast forward pretty much a year and 2 forward, and we get to sort of level 2 of coding assistance, where they already start to understand the repository. They start to perform some simple coding tasks, which are already becoming much more helpful. And they already start getting some feedback from the IDE. In this case, it was pretty much a syntax. So any diagnostics your IDE would have, like those curvy highlights, they could be fed into the LLM, and then LLM would act based on this. And yeah, they could do pretty much typical stuff you would expect from them. So things like code generation, code refactoring, maybe doc generation. So they still are pretty helpful, right? To give you some speed up. You could generate 1,000 lines of code in a couple minutes, but then you would need to spend some time on trying to make it work actually, or refactor it and so on. So it's not sure if it was time well spent, but it is what it is. And actually, if you look at the actual statistics on the long term and on the short term, developers indeed perceived some productivity gains. They felt more confident. They reported faster task completion and so on. However, if you look at the longer term and the longer time scale, you will see that already on the span of 2 weeks, a lot of the code generated by AI would start to churn. It would be either rewritten, it would be either deleted, or in general would require some heavy modifications. So in long term, any changes produced by AI would be essentially waste of time. Now, why is that? Well, all of the assistants, all of the AI coding assistants are based on LLMs, as you probably know. And the LLMs are trained to predict essentially the next probable token, right? The next probable symbol, which means that, for example, if we start typing PUB, the next probable symbol would be LIC, because public is pretty common word in Java, right? And they also trained on a lot of open source data, which means that they know about any open source frameworks. But if you start using them, if you start applying them to any of your internal company frameworks, which LLMs have no knowledge about, they start to fail just because they have no idea what the hell is going on. They have no prior knowledge about this framework, and sure, you can provide some documentation for them as a context, but this would also eat up the context window, which also would result in not so good results. But of course, that's not all sort of failure modes for them. They also struggle with logical reasoning, and especially utilizing facts, especially if they are formatted in a way which sometimes might sound a bit quirky. For example, this phrase, Tom Cruise is mother's son, it does sound kind of weird for us, but still we understand what's going on. Unfortunately, LLMs tend to fail, and I think this is pretty popular example of this fail. And in this case, it was from O1 preview, which at that time was pretty sophisticated model. Still, it failed to essentially reuse essentially understand the answer which wasn't right inside the question. And if you think that neural models would succeed here, here's a time well spent on 40-minute reasoning from O3 Pro, which pretty much concluded, well, different answer, but still not the correct answer. And yeah, 40 minutes of compute for that would be probably a couple $1,000, I would imagine. So, not very sophisticated. And of course, they also lack grounding in the physical world. So what I mean by that is LLMs don't have access to your local machine, for example. They don't have access to internet and so on, which basically means that they are limited to what they learn from open source data, and they are also limited to what they learned at that time. So usually LLMs have some sort of knowledge cutoff, which means that they still kind of think that it is still, I know, October 2024, and all the new events happening after that would be completely lost for them. They would have no knowledge about this. And this is especially problematic when we are talking about new frameworks, new versions of the frameworks coming in, and LLMs have no knowledge about them and can help you with those. And as I mentioned, they also work well in distribution. So as long as you are working on something similar to open source data, you are fine. Once you start using any in-house frameworks, you are pretty much starting to fail, or LLM starting to fail to help you in those scenarios. Now, let's switch to level 3, and where we are basically now. And I call it a sort of a junior software agent. And at this stage, LLMs already start to become, AI systems, starting to become much more involved into your project. They now have access to your environment. They can, for example, run the code. They can test the code and so on. And based on that, they can also get some feedback. So let's say they generated the code. They tried to compile it. It failed. Then they see the error, and then they can act based on that error and hopefully fix the issue and give you the working code. Now, these advancements are due to, I guess, two main things. First of all, of course, models are becoming better and better. And so here, for example, is from a comparison table from the release of Gemini 2.5 Pro. And in the red, I squared the 3 coding benchmarks, which you might have heard about. Now, of course, whenever the new model comes in, they get better results on the benchmarks. Although in this case, the coding benchmarks are not beaten by Gemini. And the problem with those benchmarks is they don't really represent our developers' everyday life one-to-one. So what I mean by that is if you look at, for example, at either Polyglot, the tasks there basically require LLM to implement a single function, a single method inside the class to fix some issue, to fulfill some task. And reality of development is not as simple, right? We usually require modifications across multiple files, maybe even across multiple repositories. And even though models become better at modifying specific methods, they are not necessarily getting better at modifying the whole repository, for example. But that's sort of part of the improvement. Another part is AI agents. And if you recall, I called the third level as junior software agents. And the agents is probably the thing which hopefully you all heard. And this is what everybody is talking about. And let's first define what is agent. Now, we can define AI agent as a software that performs tasks on behalf of a user. On its own, this sounds pretty much like any software, right? So any software, any classical software perform tasks on your behalf. So what's the difference? Well, the main difference is agents, AI agents follow sort of these 4 design patterns. First of all, they can use tools. So that could be, for example, web search. That could be running bash command, could be access to file system. So essentially any tool you give agent access to, it can use to get better results. It can also do planning. So it doesn't just simply generate the code or whatever you asked it to do. It can start with some sort of step-by-step plan and then act based on that plan. They can also reflect. They can reflect on their own work. They can reflect on each other's work. So essentially, they can, for example, first generate a plan. They then use some tools to update their knowledge, and then reflect based on new knowledge coming in to update and reflect on the initial plan. And of course, there is also multi-agent collaboration, where multiple agents could potentially interact with each other, helping each other to get a better plan, helping each other to generate better code, and so on. Now, why is this important for us, for developers? Well, if we look at how developers actually spend their time, and this is based on the research done 10 years ago, although I think it is still pretty much the same distribution. So we will see that understanding essentially occupies 70% of the time developers spend in their work. Surprisingly, it's not drinking coffee, but yeah, I guess you need to drink a lot of coffee to get better understanding. Now, if we sort of overlap those agent patterns with this diagram, we will see that, of course, for tool use, you need to do editing. You do use tools when you spend time outside of IDE, and UI interactions are essentially also tool use. Then for the planning, of course, you need to understand. You can just plan something without understanding what's going on, and yeah, probably need some navigation and spend some time outside of IDE. Same with the reflection. You can't reflect on your work without understanding what's going on. And then, of course, for multi-agent collaboration, most of us work in teams, so we do interact with each other, hopefully in a positive way. We can help each other, we can plan together, we can reflect on our work. So essentially, this multi-agent collaboration covers pretty much most of this diagram. Now let's. Why doesn't switch? Okay. Now let's do a brief coding session and see how all of those patterns can help you already become a bit more productive through AI, or how AI can help you be more efficient. So yeah, all the code is available on this QR code over here. So let me, how much time I have? Okay, let me switch over here. So first we will start with sort of baseline, where LLM doesn't have any access to tools, it doesn't have any planning capabilities, and so on. So essentially, it's just a plain vanilla LLM. In this case, it's called Sonnet 4. So let me run all the code here. And then I'm asking the LLM pretty simple questions, which us, as humans, would be able to answer pretty easily, right? So the response time for Google, unfortunately, of course, it doesn't have access to Bing or whatever. And well, it does provide some commands for us to use, but it's still can't do it on their own. Same goes with the Python packages. So it doesn't have access to my local machine, of course. It does provide some helpful suggestions, but it still can't execute them on its own. And the same goes with the newest Java, for example, Java 24, which I think was released in March 2025. The code has the knowledge cutoff, I think, of June 2024. So at that time, of course, there was some news about Java 24, but still it's sort of like a kind of speculation. So you can see it's slightly features, so it's not really necessarily really reflective of the reality. And if you would try the same question with the older model, like Claude 3.7, for example, it would completely fail, because at the time of its training, it didn't even hear about anything about Java 24. So, it provides some potentially helpful suggestions or answers, but not really that helpful, right? Now, let us switch to more kind of sophisticated scenario. In this case, we will give to the model access to tools, and all the different planning capabilities are already actually built into the Claude Sonnet 4. So we won't be implementing anything specific for that. But basically over here, what I will be doing is I will be giving the Sonnet, first of all, the ability to do web search, and I will also be giving access to a few tools. Won't be going much detail in this code, but basically, I will be giving it access to file system tools, so it can read files, it can create directories, list directories, so essentially do any file system modifications. It can also fetch URLs, and it can also execute bash commands. So let's see what will happen now on pretty much the same question about Java 24. Now in this case, it will it should decide to use web search. And the web search I'm using here is from Anthropic itself. As you can see here, it is their Anthropic's web search, which sometimes can be a bit slow. But on the positive side, it can provide much more information to LLM. And yeah, unfortunately, Anthropic's web search still kind of slow. Let's see. Hopefully, it will be able to give us what is new anytime now. Well, anyway, while it's doing the search, okay, finally. So yeah, as you can see, it decided to do a web search for information about Java 24. It got, I think, 10 web search results. Check the URLs, and then based on those web searches, it provided us up-to-date information about Java 24, which was released on 8th March. All the different features, a lot of different features. So essentially, it was able to get up-to-date knowledge pretty easily, although a bit slow for the web search, but still it was able to give you much newer results. The same goes with this example. So here, for example, I have the fail.py file, which, as you can guess from the name, will fail to run. So we can see how Claude will use different tools to act based on those errors. So first, it decided to find the file, decided to check the content of the file. So the code itself actually fine. The problem is with the environment setup. I don't have pandas installed, in this case, this library. So Claude tried to run using bash, tried to run this script, it failed. And then based on this error, Claude was able to act and essentially, in this case, install the library, and then hopefully the code will work now. Yeah, so the code now works. So essentially, Claude was able to, I guess, sort of recover from any errors which were initially present in the code or in the environment through the different tools. So essentially, was able to access my local machine, see the errors, plan the fix, and execute it. And in the end, it got the actual working script. So the same would go with the Docker file. I won't be running it for the sake of time, but essentially would be pretty much the same scenario. Now that's level 3, right? So let me get back to level 3. Now, what would level 4 and 5 look is it is more about automation, so making agents fully autonomous. And I would call this, level 4 would be mid-level, sort of software agent, and then level 5 is product agent. So at level 4, we can get more end-to-end testing. So agent is much more deeply involved into the whole process, into the whole DLC. So it can be part of CI/CD, it can interact with UI, essentially do the whole end-to-end test, interact with other agents. And then level 5, it will be fully autonomous. It would be potentially able to interact with users, for example, and act based on that. And those dates are sort of just my guesses. And of course, when we are especially talking about AI, guesses are not always come to fruition. Like, for example, these two predictions, they didn't come through. But yeah, I still think that those estimates are more or less correct. And to give you a quick glimpse of what this level 4 might look like, because we are already short on time, I will quickly switch to, first of all, to this website, which you might be familiar with. So over here, I have this button, Add to my calendar, which basically opens up these 2 choices, which will redirect me to the calendar. Now, with our agent, Ads Encoder, we can, let me switch to VS Code, sorry. Come on. All right. So with our agent, end-to-end agent, which is still in beta, you can essentially ask the agent to go ahead, check the same behavior that it works. Right, so go to this website, check the button, opens the calendar selection, and redirects to Google Calendar. And well, in this case, of course, I don't have access to the actual code of the website, right? But still, it is able to, should be able to. Let me actually open the test run I did in the evening. So essentially, it would, just for the sake of time, it would navigate the browser, click around, check all the buttons, check the redirects, and then generate the tests for this flow. Or if it would have access to the actual code and something would fail, it would be able to go ahead and fix that for you. So essentially, it would be able to ask it to verify that your code works, and it works end-to-end, right? With the API, with the UI, and so on. Yeah, so let me get back to the slides. I think I have 1 minute left. So let me quickly go essentially to these final words. So yeah, as you've seen on my source prediction, this goes to 2027. So you might think that, well, developers have 2 years left. Now, of course, you can think about this as a positive thing. Maybe you can finally go ahead and chase your dream after working for a long time at Microsoft. And well, on the other hand, of course, you still can train AI without without getting some data. So there is still this job left, at least. But seriously, especially if even if you're talking about vibe coding, you still need to understand what's going on. So you can't really just produce the code and be done with it. When you're talking about production, you still need to be able to get a full grasp, at least on the product level, on what's going on the code, and so on. But yeah, seriously, we think that AI will become more of a copilot, a true copilot. It's not going to replace the developers. It will augment them, and we as developers would become more of managers rather than writing code ourselves. We would be sort of managing the army of virtual junior developers, reviewing the code, and yeah, basically telling AI what to do, and us ourselves just drinking coffee and reviewing the code. And yeah, I don't know. For some reason, for some people, it might be a sort of gloom future, but yeah, I guess it is what it is. And a few QR codes at the end. This one on the left, you can get my contact details if you want to connect. And on the right, there is a QR code for our website, for Zencoder. So if you want to try us out, if you want to try out end-to-end testing agent, for example, feel free to try us out. We support both with Kotlin JetBrains. So happy for you to try us. And with that, thank you for attention. I think I'm almost at time. So yeah, we'll be happy to answer any questions. Yeah.
Hi, thank you. Thank you for the presentation. What do you think about the most advanced AI solutions that we have right now for the software development? What we as software developers can do that is still not being able to be performed by the existing AI solutions?
Yeah, that's a good question. Well, usually a lot of people would say that like AI is still failing at creative tasks, but you've probably seen a lot of AI generated videos recently, which kinda contradicts that point. But still, if we're talking about software development specifically, AI still kind of fails to grasp the whole picture, especially since it would require connecting to a lot of systems, right? So when we are working on the Jira ticket, it's not just about writing the code, it's also about understanding the requirements from the product, from the users. It's about understanding maybe deployment strategies. So basically, there are a lot of things which resolve around just writing the code, which would require AI to get much better understanding sort of high-level picture. So as I mentioned on this slide, we would become more of managers, and being a manager kind of involves understanding more of a high-level picture. So at least for now, AI is still failing at this. So that's essentially one of the things. Another thing would be, I guess, well, in a sense related to what I just said with the high-level picture. Just again, because AI, when it writes the code, it usually doesn't have access to the whole surrounding systems, again, deployment, testing environment, and so on. So, it still can produce code which would be failing, right, in the real life world, but it won't be able to know about this unless you actually give it access to those tools.
I don't know if I have time, but I would reformulate my question like this.
Okay.
Because many people who are actually not very familiar with software development, they may get a fake impression that they can really do software development just by using AI because they are not really experts, and they may come to you and yeah, I can do whatever I want. Why do I need you? Then how would you convince them?
Yeah. Well, as I said, there is much more to software development than just writing code, of course, right? So you might have seen the recent thread on X where some guy used Cursor to wipe code the website, and then all the bad things started to happen because Cursor just put his API keys in the plain text on the website or something like that. And you still need to understand the basic concepts about security, about the deployment, all this stuff. And sure, you can create some sort of MVP easily, right? You can, I don't know, create a website or a simple app. But if we are talking about, again, about the whole full-blown product, it involves much more than just writing the code. All right, thank you.